Alright, let's take a look at this thing and see if we can figure out what's going on here. So, got two forces of interest here. You've got the tension and you got the gravity. It's always helpful, or usually helpful, to draw a force diagram or a free body diagram. Alright, and then with the tension, there's two components to the tension force. There's the horizontal component, which is going to be the centripetal force, and the vertical component, which has to be equal in size to gravity, otherwise the ball would not move in a horizontal circle. So they want the angle the string makes with the vertical, so that angle that's being requested is this theta, and knowing that, the legs of the triangle here that are made by those two vectors, this one would be t cosine of theta because it's adjacent and that's the hypotenuse, so t cosine of theta, and that one would be t sine of theta. Right, and try and get a, well, I guess let's try that again. Alright, there we go. So when you go through and try and work out all this stuff to solve, so we sum the forces in the y direction. It's going to be 0 equals t cosine of theta minus mg. So essentially what we're saying there is that t cosine of theta equals mg, and then the in the x direction is going to be a centripetal force because there's circular motion in the horizontal direction. So mv squared over r, and that's going to be equal to t sine of theta. Alright, so they wanted you to find the angle, and they wanted to find the tension in the string. I think the tension in the string, I don't know, let me walk that back a little bit. Alright, so I'm going to try and put these two expressions together in a way that'll be useful here. So, let's see, if I take that y direction expression, or equation, so, and solve it for t, it would be t equals mg divided by cosine of theta. And then if I take that and put it in place of the t here, then I would have mv squared over r equals mg over cosine of theta times sine of theta. Alright, and some useful things will happen here, such as the mass will cancel out, and then sine over cosine of theta is equivalent to tangent of theta, so this becomes v squared over r equals g tangent of theta. And let's see, if I wanted to know the angle, then I think I could actually solve that now because we know the speed, we know the radius, and we know g. So yes, that is what we want to happen here. So I'm going to move the g over to the other side. And once you get to this point, then you plug in your values here, take the inverse tangent, and you'll be able to come up with the angle. Once you know the angle, then you could come back up here and plug that angle in to, say, cosine of theta here. You know the value of mg, so you can solve for t. So that should clear things up there.